Hello, welcome to this interactive AERZEN webinar presentation on pneumatic conveying applications. Before we start, let me ask you a question. Can you imagine your life without bread, pizza, chocolate, coffee, or medicines? No, right? It's the same as imagining your life without industrialized pneumatic conveying applications. In 2020, global bakery products reached a value over $500 billion. The global confectionery market was almost $200 billion, and the global chocolate and coffee market reached over $100 billion. On the other hand, the global plastic market reached over $500 billion in 2020, from which over 50% belongs to the food packaging industry. Hi, my name is David Salazar, AERZEN Manager for Pneumatic Conveying Applications. Thanks for joining us today. In this webinar, we will be clarifying key concepts regarding the importance of applying the right pneumatic conveying knowledge into the blower or compressor selection to guarantee a swift and smooth material conveyance along the production process in many different food segments. In this webinar, we will be reviewing three main sections. First, pneumatic conveying and its different methods. Second, optimizing technical solutions according to the application needs. And third, addressing common pneumatic conveying setbacks. We will begin by answering the question, what is pneumatic conveying? It is a process in which bulk materials of almost any type are pushed or pulled using gas flow as the conveying medium from one or more sources to one or more destinations. Now that we have the pneumatic conveying concept clear, let's discuss the differences between dilute and dense phase methods. Basically, the main difference will depend on two main factors. Can you guess which answer is correct? If you selected option B, you were correct. Material characteristics, piping requirements, and speed are the most critical variables to decide whether a lean or dense phase method will be the best option. Let's see this concept through the main characteristics of both possible conveying methods. Dilute or lean phase. The material is completely suspended in the air or gas stream. The solids loading ratio is low, between 0 and 15. The manometric pressure is low, lower than 1 bar. The pickup velocity is high, between 15 and 28 meters per second. The terminal velocity could be 1.5 times the pickup velocity. The total pipeline system is limited to 120 meters. Dense phase. The material is not suspended in the air or gas stream. The solids loading ratio is high, between 20 and 150. The manometric pressure is high, between 1.5 to 10 bar. The pickup velocity is low, between 3 to 10 meters per second. The terminal velocity could be 3 times the pickup velocity. The total pipeline system has no limitations. Now that we have more information about the differences between dilute and dense phase, let's discuss which method can be applied for pressure and vacuum pneumatic conveying systems. Let's watch an animation explaining both pressure and vacuum systems. After watching the differences between a pressure and vacuum system, can you tell which method is optimal for a dilute or dense phase? Let's see the options. If you selected option D, you were right. There is no preference from the method or system when the material characteristics, piping total distance and speed are not considered as a part of the analysis. In summary, both methods and systems can be combined. Now that we have a basic understanding of pneumatic conveying systems and its interaction with the products we consume daily, which variables do you think are critical in a pneumatic conveying system in order to guarantee a food safety standard in the products we eat? If you selected option B, you are correct. To guarantee the necessary food safety standards, then the system must contain 100% pure and reliable process air, certified oil-free, absorbent-free assemblies, and extensive explosion-proof solutions, such as ATEX. AERZEN works hard to guarantee and maintain the features mentioned in order to have 100% product purity within food processing. Now it's time to apply these concepts while looking at some of the main industries in the food market. Let's start with the baking industry. What do you think is the main raw material needed to produce bread or pizza? Had enough time to think? Did you guess flour? Flour is the main raw product to the baking industry. In 2020 alone, 765 million metric tons of flour was produced worldwide, meaning that over 87,000 kilograms per hour of flour was pneumatically conveyed worldwide. This is a massive need of oil-free air because this flour is conveyed to over 9,000 bakery production facilities worldwide. Flour is a material with good air retention, which is a particle capability in order to retain airflow as it passes through, and has a light and small particle size and a bulk material density of 540 kilograms per cubic meter. Flour is produced in flour mills, where pneumatic conveying lines are used for storing and packaging the final product. Both applications use a dilute phase pressure system combination.
Once the flour arrives from the mills to the baking industry plants, pneumatic conveying lines in a stationary bulk unloading system is by means the most commonly used and best energy efficient system to unload trucks, as well as the best food safety solution to avoid cross-contamination of the material. Bulk unloading application uses a dilute phase pressure system combination and has the following characteristics.
Short piping distances between 20 and 50 meters. The most common nominal diameters are DN125 and DN150. A high pickup speed between 25 to 30 meters per second. And a mid-low differential pressure between 600 to 1500 millibar. For this specific application, AERZEN has global experience as a solution supplier with the Delta Hybrid H model, which can reach up to 1500 millibar differential pressure capacity and helps stationary bulk unloading systems to improve efficiency by unloading a 34-ton truck in 50 minutes.
The Delta Hybrid Rotary Lobe Compressor is one of the most innovative solutions in compressor technology and one of the most efficient machines by far. AERZEN Delta Hybrid has long been the only packaged unit in the world to bring together the benefits of blower and compressor technology in one single unit. With easy handling and minimal maintenance, these are characteristics that have a direct impact on efficiency to our customers' bottom line. Key Delta Hybrid advantages are control range between 25 and 100%, reduced pressure and airflow losses, belt-driven for precise volume stream determination, reduction of noise in the discharge muffler by retouring airflow instead of absorption material. The downstream process system won't be contaminated. Certified as a spark extinguisher meeting ATEX regulations for explosive environments. Patented bearings with a nominal lifespan of more than 60,000 hours of operation. Patented driving and conveying chamber sealings. 100% oil-free Class 0 air supply.
Now let's discuss the confectionery industry, which includes candy, chocolate, and chewing gum, among others. The main raw material for the confectionery industry is sugar. In 2020 alone, over 160 million metric tons of sugar was produced globally, in which 40% was consumed by the confectionery industry, leaving a total consumption of over 66 million metric tons. This means that over 7,500 kilograms per hour of sugar was pneumatically transported globally, requiring an average of 3,700 kilograms per hour of air mass flow to convey the sugar to over 12,000 confectionery locations worldwide. Let's take a look at the typical characteristics of the sugar used to produce these products. Sugar is a material with bad air retention. It is very lightweight and has a medium particle size. Its bulk material density is 860 kilograms per cubic meter, and it is highly explosive when handling as bulk material. Once the sugar arrives at the confectionery production plant, pneumatic conveying lines are used for mixing and storing it, with the specific requirements such as the conveying system being totally enclosed in order to avoid cross-contamination and guarantee an explosion-proof system. The sugar temperature must remain below 70 degrees Celsius in order to avoid it from softening. Also, an important consideration to ambient conditions must be considered because of condensation and relative humidity issues. AERZEN provides a complete solution with dehumidifiers and air-to-air cooling systems for this important application. The sugar mixing application uses a dilute phase vacuum system combination and has the following characteristics. Short piping distances between 10 and 30 meters. The most common nominal diameters are DN80, DN100, DN125, DN150, and DN200. A high pickup speed between 15 to 18 meters per second, and a low differential pressure between 150 and 400 millibars.
Sugar conveying in the confectionery industry is one of the top applications where the AERZEN Delta Blower product line is a perfect solution to guarantee all demanding requirements such as food safety, certification to operate under explosion-proof environments, long maintenance intervals, and high reliability. AERZEN Delta Blower delivers the best combination from product expertise and application knowledge when dilute phase conveying methods for both pressure or vacuum systems are required. The Delta Blower Generation 5 is the synthesis of the successful characteristics developed in previous generations combined with new technical innovations that already meet the market requirements of the future. AERZEN Maschinenfabrik was the first blower manufacturer to design compact units in 1960 and has developed this machine type continuously ever since.
Lastly, the food-grade plastic industry has a major part in food applications due to its widely used packaging methods for several industries. Even with worldwide environmental pressures on reducing plastic production, 2020 alone had 367 million metric tons of plastic produced globally. Approximately 70% of total production is used for the food and beverage industry, which is an astonishing 257 million metric tons produced. This means that almost 30,000 kilograms of plastic pellets were conveyed every hour globally in 2020, requiring an average of 900,000 kilograms per hour of mass airflow in order to convey the material to over 160 petrochemical plants and 90,000 plastic manufacturing facilities worldwide. Let's take a deeper analysis on the material characteristics to produce this massive amount of food-grade plastic packaging. Polypropylene pellets are a material with bad air retention or high air permeability. They have a medium weight and big particle size. Their bulk material density is 500 kilograms per cubic meter. The petrochemical plants produce the polypropylene pellets, and the plastic processing plants use the pneumatic conveying lines for packaging, storing, and conveyance processing. The polypropylene pellets conveyance process application uses a dense phase pressure system and has the following characteristics. Piping distance is relative to system needs. The most common nominal diameters are DN120, DN200, and DN250. A low pickup speed between 3 and 10 meters per second, and a high differential pressure between 2 and 3.5 bar.
AERZEN Delta Screw product line has been by far the most reliable technology available to create pressure for the pneumatic transport of powders and granulated materials of almost any type when dense phase conveying systems are required. The single-stage, oil-free screw compressors in the Delta Screw Generation 5 Plus series are universal tools. They bundle all the know-how of a world market leader in compressor technology to offer the maximum efficiency and reliability to our customers. These innovative machines are belt-driven to pressures up to 2000 millibars with the AERZEN Delta Screw VML Generation 5 series, and direct couple when pressure requirements need to reach 3500 millibar with the AERZEN Delta Screw VM Generation 5 series. The flexible modular system allows for almost any combination of compressors and accessory components. Energy efficient, reduce life cycle costs, high reliability in operation under demanding conditions, significantly reduce noise levels, ATEX certified for spark suppression, space-saving compact design, user-friendly and low-maintenance operation.
As you can see, AERZEN technology can fit different applications and industry segments with the Delta Blower, Delta Hybrid, and Delta Screw models. However, we haven't mentioned a very important technology AERZEN introduced into its portfolio over 15 years ago, the AERZEN Turbo, a centrifugal operating machine suitable for specific lean phase applications, having the lowest maintenance cost, reduced footprint, and a completely oil-free operation. The AERZEN Turbo series has been extensively used in the water and wastewater industry for several years, saving millions of kilowatts consumed worldwide thanks to its remarkable operational efficiency. The AERZEN application specialist team in Chile found particular synergies between the AERZEN Turbo technology and specific market needs. The team introduced the technology into the pneumatic conveying segment, precisely for salmon farm feeding applications. Chile is the second largest salmon producer worldwide, with over 800,000 metric tons of salmon being produced in 2020. Usually, the farming process is challenging because the electricity needed from diesel motors come at a high operational cost, and its availability is lacking. Additionally, the oxidizing environment caused by salty air moisture represents a challenge because of corroding electrical parts. The AERZEN Chile team recognized the need for having a reliable, robust, and efficient farm feeding system and presented the AERZEN Turbo technology for this challenging application. The AERZEN Turbo performs as a perfect fit for offshore operation thanks to its stainless steel impeller to avoid material rusting, corrosion-resistant electrical parts, and low electrical power consumption. At this point, we have already covered the first two segments proposed for this webinar: the different methods of pneumatic conveying and optimizing technical solutions according to the application needs. Along the 155 years of AERZEN's knowledge in the industry, we have learned that pneumatic conveying systems don't always work properly for its main purpose, which is to guarantee a swift and smooth material conveyance from point A to point B. There are several reasons why a system can cause trouble for its conveying rate, and now we will focus on 3 common reasons why. First, pipe plugging or buildup. Second, throughput restrictions. And third, abrasive wear and particle attrition. All 3 causes may be solved by considering the following items: material characteristics, pickup velocity, ambient condition, and poor line layout. Material-related issues. Materials with high fat content or highly adhesive reactions to high temperatures, such as cake and cookies powder, powder milk, or localized material melting. AERZEN's recommendations are to increase a pipe diameter section to reduce conveying speed and system temperature. Fitting issues. Material fitting is not steady or material fits batches into the pipeline. Blower or compressor capacity needs to be set to the maximum pressure available within the specific motor size in operations. Ambient condition related issues. Condensation, high ambient relative humidity, and high intake temperature. AERZEN's recommendations: reducing ambient relative humidity to a value below 30% secures almost any system from reaching the dew point due to ambient conditions. A dehumidifier with an aftercooler is a great solution for both condensation and high intake temperature. Poor line layout related issues. Too many elbows or being too close to each other. AERZEN solution: maximum 2 elbows in a row, or increase differential pressure capacity and mass flow in the system. Reduce acceleration before the elbow. For dilute phase, the recommendation is 25 times the pipe diameter distance before the first elbow. For dense phase, the recommendation is 10 times the pipe diameter distance before the first elbow. Incline lines. This is critical, especially in dense phase conveying, because the pressure losses due to increased friction are too high. If pipe layout can't be modified, then the differential pressure in the compressor must be increased to its maximum capacity. Thanks for listening to our webinar. Here are 3 key takeaways in which AERZEN can support your specific needs for pneumatic conveying applications. First, adjusting your conveying method in order to account for the material characteristics. Second, optimizing pressure capacity in order to optimize your conveying rate. And third, understanding the relationship between mass airflow and speed in order to enhance system capabilities. Thanks again for joining us in today's webinar. We hope you have enjoyed this journey through pneumatic conveying applications. Remember to get in contact with your local AERZEN entity in your region if you have any specific request. Thank you.
Expect performance. Expect performance.